Hello everyone, so welcome back to Educational Era. Today we'll be starting a new topic called simple harmonic motion, and this is the first video in this playlist. So let's get started. Today I'll just talk about what is simple harmonic motion, and I hope you will learn something. Before we start, make sure to subscribe and like this video, right? And share it to your friends. So simple harmonic motion. So simple harmonic motion can only be understood if you know two other things. That is, first is periodic motion, and another is going to be our harmonic or oscillatory motion. Alright, so what is periodic motion? I will just describe both of them with a diagram and an example. So first, moving on with periodic motion, let's see what is periodic motion. So basically, periodic motion is a type of motion that you see in our when our sun revolves around the earth, right? So let's say this is our sun, right? Sun, and there is our earth right here. This is our earth. Now as our earth moves around the sun like this, it eventually, after 365 days, it returns back to its original position, right? So this type of motion, in which an body return back to its original position after a certain interval of time, is a periodic motion. Alright, likewise, there is a specific type of periodic motion that you will have to know before knowing simple harmonic motion, and that is oscillatory motion. Well, this planetary motion that I just showed you is not an oscillatory motion. Why is it not an oscillatory motion? Well, for an body to be oscillatory motion, to have oscillatory motion, it should move to and fro about its mean position. That is the number one requirement for oscillatory motion. But now if we look at this planetary motion, then you will see that the earth is not moving to and fro. It's just moving, it's just revolving around the earth, right? It's moving in circles, it's not to and fro. So if we take an example of an oscillatory motion, then you can very well take this swing, for example. So this is a swing right here. Now as you pull the swing up till here, right, and you let it go, then you'll find that the swing just keeps on moving from here up till maybe here, and from here to again here, right? So this right here is our oscillatory motion, because a body is moving from one single fixed point to another fixed point, to and fro, right? So that right there is oscillatory motion. And now a oscillatory motion of simplest type is called simple harmonic motion. Well, let me just read the definition of a book I have in my side and you'll know what I mean. So harmonic motion of simplest type, in which there is constant amplitude and frequency, is called simple harmonic motion. Alright, so what did I just say? So let's take this oscillatory motion right here, right? So let's take this right here. Remove all of let's remove the periodic motion from the board right here. Now in this oscillatory motion, if you see the swing right here, after a certain time, right, if you ever experienced the swing yourself, then you'll know that the swing just slows down and eventually stops, right? If we plot it in the graph, then you'll see that the maximum displacement, let's say this is our y, right, So maximum displacement over a period of time will keep on decreasing for the swing, right? It will be like this. So this right here is not a simple harmonic motion. This is not going to be a simple harmonic motion. For a body to have simple harmonic motion, it should have, one is constant amplitude, another is single frequency. So let's see how we can make this swing a simple harmonic motion, right? Let's just make a brand new swing, right? Here is our swing, right? And we will pull the swing from, let's say, let's pull the swing up till here, and let's let it be free, and after a certain time it will get up till here, and it again starts to move back from here to again here. Now if this swing, after moving back up till here, if this, the displacement that it travels remains constant, right? The maximum displacement it travels, for this case let's say this is y, if this swing travels the same displacement over every oscillation that it does, then that right there is our constant amplitude, simple harmonic motion, right? So there is another condition, that is it should have single frequency. Well, that just means that as it is traveling the distance, right, is the constant distance, it should travel the constant distance in equal period of time, and the distance it travels in 1 second, the number of oscillation it does in 1 second should remain constant. If that condition is satisfied, then this motion right here is called simple harmonic motion. Now let me just write down the definition for simple harmonic motion, then you will understand even more what simple harmonic motion is, and we can stop this video. So simple one more thing before we leave, right? So to find the acceleration, we know that acceleration is velocity times the time, right? By time, right? So again we know that velocity is distance by time, so that means acceleration is going to be distance by time square, right? And we know that frequency is going to be 1 over t, so acceleration is distance into frequency square. Then that means that acceleration, since frequency is going to be constant, for a simple harmonic motion acceleration is directly proportional to the distance traveled, right there. That is the condition that should be satisfied for a body to possess simple harmonic motion. So while writing the definition, instead of all this constant amplitude and frequency, we can simply write that a simple harmonic motion is an oscillatory motion where acceleration traveled by the body is directly proportional to the displacement, right? That is going to be, that can be the definition too. And let's just revise what we just said. So simple harmonic motion is a type of periodic motion at first. And what is periodic motion? Well, simply it's a motion in which a body returns back to its original position after a certain interval of time. Now if we move to oscillatory motion is a type of periodic motion in which there is to and fro movement of a body, while the moment is not going to be an angular or rotational motion, but rather it is going to be a motion from one fixed point to the other fixed point, right? There's going to be two fixed point and the body is going to move to and fro. Now for an oscillatory motion to be simple harmonic, there should be two conditions. One is it should have constant amplitude, and other is it should have single frequency. So for a body to have constant amplitude means it should travel the same displacement over the same period of time, right? And single frequency means simply how much oscillation it does in 1 second, which should remain constant, right? For a body to be simple harmonic. And we wrote down the definition, and that's basically it. That is our simple harmonic motion. Well, you can screenshot this right here if you would want, and I hope this makes it clear on what is simple harmonic motion. And now in our next video we will be talking about the equations that we can get from simple harmonic motion and dive a little bit deeper into simple harmonic motion. If you have any suggestions for any videos, then make sure to comment it down below, and make sure to subscribe, yeah, and share it to your friends. Thank you so much for watching.